This video is to review basic math skills to prepare you for the placement tests here at KCC. This is not meant to replace a course or instruction if you do not yet already have these skills. Some students find that they actually have these basic skills but had not used them for so long. Therefore, they didn't do well on the placement test and were placed in a course below where they should be. The purpose of this video is to review the basic skills in order to avoid being underplaced in the math courses. You should have received a link to a Basic Math Skills worksheet. It looks a lot like this. Each row has a problem that we will demonstrate, a problem you can do on your own, and then a link that helps you get to more practice on any topic. When you click on the link, again, be certain that when we do this, we hold down the control to click on the link. You will get a website that looks very similar to this. This is mathdrills.com. It is not affiliated with a college, but it is a wonderful resource for all sorts of worksheets. I gave the link to the A, or the first worksheet. If you go to the bottom, scroll down, you'll notice that there are also B, C, D, and other versions of the same worksheet. You can practice as little or as much as you need in each of the topics if you happen to find one that gets a little bit confusing. When you print, you can also find that every worksheet has not only the questions, but the answers on the back. So you'll have the answers right there to check them as you go. Again, you can do as little or as much on each topic as you want, but I highly recommend that you go through every single topic in the worksheet to make sure that you've covered all of the material. Okay, so now that we've seen the worksheet, we know how to do the video, let's start working on the work. Before we begin this video, please make sure that you've printed out a hard copy of this worksheet. The electronic copy is very handy for clicking on the links and getting to extra worksheets, but having a hard copy is really beneficial at this point. So let's look at the first one. We're going to round 2,641 to the nearest thousand. So I've got to count out and find my place values. So this is ones, tens, hundreds. So this is the place value that I want to round it to. This is the number that's going to change. So what I do is I look behind it to see which way it's going to go. Remember, if this number behind it, not the one I want to round, but the one behind it, is between 0 and 4, then this number here stays in place. If this is between 5 and 9, which it is, the number that I want to round goes up to the next number up. In this case, it's 3. So then every number behind it has to become 0. So 2,641 rounded to the nearest thousand becomes 3,000. On your own, try rounding 47,637 to the nearest hundred. Again, I'll get you started. Remember, this is the ones, tens, hundreds. So this is the place we're going to round. Go ahead and pause for a moment and see if you can't do it. Again, the number behind it is the 3 right here. And because this is between 0 and 4, this told us that I have to keep this rounding number here at 6. Everything above it doesn't change. Everything behind it stays 0. And again, click on the link if you want a little bit more practice in this area. Let's look at the next one. This is addition. We have 40,267, and then we're going to add each of the other numbers, lining them up, and then adding. And then we're going to add straight down. So I have 7 plus 2 plus 7 is 16, and we put the 1 up here. 1 plus 6 is 7, plus 4 is 11, plus 5 more is 16. 1 plus 2 plus 8 is 11, carrying the 1. 1 plus 0 plus 7 is 8, and then 4 added to nothing else gives us 48,166. Take a moment to pause the video and see if you can't add these together. The answer will be up in a moment. This should be your answer after you line them up and add them together. Again, the links beside it will help you if you need any more practice in this area. Now on to subtraction. We're going to line these up again, line the place values up as we see them. minus 17,227. So what you have to do is work from the right and evaluate each column row by row, or column by column, excuse me. So I'm looking at 5 and I'm trying to take away 7, and I can't do that. So what I'm going to do is I'm going to borrow from the 4, knock that down to 3, and then I'm going to put the 1 here. I'm basically borrowing 10. So now I can do this. I can do 15 take away 7, which I know is 8. 3 take away 2, I can also do. I don't have to do any borrowing. The larger is, or the top is larger than the smaller. Here, I can't do this. I can't take 2 away from 0, so I'm going to have to borrow again. Make that 10, which borrows it from here. And I'll worry about this later. 10 minus 2 is 8. And then I have to go here. Well, I'm trying to take 7 away from 4, which I can't do. So one more time I have to borrow. 14 minus 7 is 7. And then 1 minus 1 is nothing. So I'm simply left with 7,818. Go ahead and go to the next one and try it yourself. Pause the video. You should have gotten the answer 40,547. For multiplication, we need to multiply every digit down here by all the digits up on top. So what we're going to do is we're going to go through this systematically. 2 times 3 is 6. 2 times 7 is 14, carry the 1. 2 times 2 is 4, plus 1 more is the 5. That's how we take care of the adding. Now what we need to do is we need to multiply the 6 by everything. Since we're moving one space in, I have to start my digits working one space in. So when we multiply 6 times 3 to get 18, the 8 goes here, not all the way out to the right. And then again, we always carry the 1. 6 times 7 is 42, plus 1 more is 43. And again, I'm covering up. Sometimes it helps to erase the marks from a previous set. Sometimes I just write over it, but it's definitely in a different color so I can tell. 2 times 6 is 12, plus 4 more is 16. Now I'm moving 2 spaces in, so I'm now working on the 7. So when I do here, I'm going to put 2 zeros down here. If all of a sudden I also had thousands down here in the bottom, then I would work 3 spaces in, or put 3 zeros, and so forth. So I'm going to multiply. 7 times 3 is 21, carry the 2. 7 times 7 is 49, plus 2 more is 51, carry the 5. 7 times 2 is 14, plus 5 more is 19, and we write everything down. The last step we do is we add all of our columns. So 6 plus 0 plus 0 is 6. 4 plus 8 is 12, carrying the 1. 1 plus 5 is 6, plus 3 is 9, plus 1 more is 10. 1 plus 6 plus 1 is 8, and then 1 plus 9 is 10, carrying the 1, and then we have 2. So the answer is 208,026. I'll give you a moment to try out this here. And there's the answer with the work placed before you. For long division, I have the steps written over here onto the right. What we're going to do first is we're going to divide the 5 into what we can. So the 5 will go into 8 one time. Doesn't have to go in exactly, we just see how many times 5 will go into 8 without going over. Step 2 says we multiply. 1 times 5 is 5. Then we subtract. 8 minus 5 is 3. And then we bring the next number down to 6. Then we repeat. Divide 5 into the next number. 5 into 36 goes 7 times. 7 times 5 is 35, doing the multiplying. That's step 2. Step 3 says we subtract. Step 4 says we bring down the next number. And I always like to use the arrows because it reminds me which number I've brought down and what I have yet to bring down. So we bring that down and that becomes 5. So then we have 5 goes into 15 3 times. 3 times 5 is 15. And as you see, my numbers are getting kind of large, so it looks like I'm done bringing down, but I haven't touched that 6, so that's pretty handy. So subtracting, it's 0, and then bringing the next number down, it's 6. Then I repeat. again, divide 5 into 6 goes 1 time. 1 times 5 is 5. Step 3 says we subtract, which is 1, and then we bring the next number down. I can't bring any more down. That's how I know that I'm done. Sometimes these steps look like they go on and on forever, but I continue to bring numbers down. Once there's nothing left to bring down, that becomes my remainder. So the answer here is 1,731, remainder 1. We will have decimals to deal with later on in this worksheet. Again, working through the next problem, hopefully you see that we have 367 with a remainder of 4. Again, the remainder is down here, and we write that up on top. The next problem is simplifying fractions. Now we're into the fraction realm. When simplifying, what you're trying to do is you're trying to find what number will divide evenly into both the 36 and the 42. There's all sorts of different ways to figure this out. The easiest thing I can do is think of the factors of one and see if it will go into the factor of the other. So one way to do it is I can simply whittle it down. I notice that these both have an even number at the end, so I know that they're both divisible by 2. So the top is 2 times 18, and the bottom is 2 times 21. So the common factors can cancel out. So I have 18 over 21 at this point. Just because I canceled out a factor doesn't mean I've canceled out enough. So then I often have to look again and say, yeah, there's actually a 3 that goes into both. So 18 is 3 times 6, 21 is 3 times 7. So again, the 3's can cancel out. So I'm left with 6 over 7. Now, sometimes you can look at it. I'm going to do the exact same problem again, 36 over 42. And then I noticed that they didn't have a 2 or a 3, but they had a 6 in common. So I can go 6 times 6, and this is over 6 times 7. And again, the 6's cancel out. So the result is still 6 over 7 either way. The one thing to keep in mind is when you're canceling out factors, they have to be the same number top and bottom. If I were to say that 18 was 2 times 9, which is true, it doesn't have a common factor with this 3 times 7. I have to choose the pair that has a common factor with the one on the bottom and vice versa. Go ahead and try to reduce this next problem, 6 over 21. Hopefully you found that 6 and 21 both have a common factor of 3. So 6 is 3 times 2, while 21 is 3 times 7. So canceling out the common factors, you will get 2 over 7 remaining. Next we have fraction multiplication. There's two ways to look at this. The easiest way is to always just simply multiply straight across. Your numerator times your numerator. 6 times 5 is 30, and then 11 times 2 is 22. And then we can reduce it, knowing that each of these have a common factor of 2. I take my 30 over 22, and then 30 is 2 times 15, while 22 is 2 times 11. And then again, the 2's cancel out, so I have an answer of 15 over 11. But remember that sometimes what we can do is we can actually cancel, and this is only in multiplication, we can actually cancel before we multiply. And again, let me emphasize, this is only in multiplication. So what I can look is for any kind of pair, either numerator and denominator, whether it's top and bottom like this, or across this way, that have a common factor. And I notice that 6 and 2 both have a common factor of 2. So 2 goes into 2 once. 2 goes into 6 3 times. And then I can multiply the smaller numbers. Now in this case, my answer was pretty small and easy to reduce. But if my answers were huge, my fractions were huge to begin with, this would create a huge problem. So now I have the 3 that's left here, the 5 that was here, so 3 times 5 is 15. And now I have the 11 times the 1, the reduced numbers, is 11. So if you look, I get the exact same answer, but now it's a little bit easier with the smaller numbers. As we set up this next problem, remember that anytime I have a whole number, this 12 can be written as 12 over 1, and I'm going to multiply it by 4 over 3. I'm going to pause for a moment. We'll go ahead and pause the video and see if you can't complete it. So when I did this, I noticed that both 12 and 3 had a common factor of 3, and I canceled. 3 goes into 3 once, 3 goes into 12 4 times. So what was left was the 4 times 4, which is 16, and 1 times 1, which is 1. It can be left as 16 over 1, or as a whole number, you can simply write 16. Now, just like in multiplication, when we have division, we have to put them into what's called mixed numbers. Mixed numbers into improper fractions. If you don't remember how to do that, we simply multiply the bottom by the side, and then we add one more. So 1 times 10 is 10, plus one more is 11 tenths. Same denominator always. It's over 10 here, it's over 10 there. Now I look at this one, putting this also into an improper fraction. 1 times 7, then add the 4, so I have 11 over, again, the same exact denominator. Now we're ready to divide. So what we're going to do when we divide is we always reciprocate the second, or we flip it. Reciprocal is basically a larger word meaning flipping it. So the way I teach my students is we skip the first, we flip the second, always flipping the second, and then we multiply. Skip, flip, and multiply. Once you reciprocate the second fraction, it becomes a multiplication problem. Don't try to reciprocate just this part. Don't try to reciprocate before you make it into an improper fraction. Do the work here and then reciprocate it. So then I notice, again, now it becomes a multiplication problem, which is exactly like what we did up here. The 11s can go into each other once. So 1 times 7 is 7, and 10 times 1 is 10. Again, go ahead and try the second problem. Here's the work for the second problem. I did them in different colors. I noticed that the 8, first of all, let me back this up. I noticed that I have to skip, so this first one looked exactly the same, flip or reciprocate the second, and then multiplication. Skip, flip, and multiply them together. Now that I've got it set up, then I could reduce. So I noticed that 4, with my red here, 4 goes into both. So 4 goes in here twice, 4 goes in here 5 times. With the black, that 3 goes in here 3 times, 3 goes in here once. And then what I'm left with is multiplying the 2 times the 3, which gives me 6, 1 times 5, which gives me 5. The next thing we're going to do is we're going to add fractions. Now, as a quick reminder, these ones have uncommon denominators. If I had something, for example, let's say 1/5 plus 3/5, those already have common denominators. And what we always do when we add, or subtract for that matter, is we add our tops, so 1 plus 3 is 4, and we maintain the same denominator. 1/5 plus 3/5 is 4/5. In all of these problems, whether it's adding or subtracting, they don't have common denominators, so we have to find them. In this case, I'm looking for the common denominator between 10 and 15. And what I do is I simply look for the numbers that both 10 and 15 will go into. So what I'm going to do is I'm going to start making a list of multiples. So 10 times 1 is 10, times 2 is 20, times 3 is 30, times 4 is 40, 50, adding up by tenths. And then I do the same thing with 15. 15, 30, 45, adding up by tenths. And if I notice, they both have 30 as a common multiple. And that's actually what's going to be our common multiple. So I've got the 1/10, let's make a little bit of space down here, plus the 1/15. And I know my new denominator is going to be 30, because that's what they have in common. So what we have to do is we always have to decide what I have to multiply by 10 to get 30. And in this case, 10 times 3 gives me 30. Then I have to multiply the top number as well. Doing the same thing over here, 15 times 2 will get me to this 30, so I've got to multiply the top number as well. Now, you won't be multiplying all of these numbers by the same, but they better match top and bottom. I have 3 times on top and bottom. I have 2 times on this top and bottom. And then don't forget to add them together. So now, just like what we did up here, we're going to add the numerators. 3 plus 2 is 5, and then keep it over the same denominator. Now here's the thing, no matter what operation you do, if you'll notice, I have this item needs to be reduced. So I have 5 over 30, which reduces down to 1 over 6. 5 can divide into both of them. Go ahead and try to find this one here. Find the common denominator, change your fractions like we did, and then add them together. So here's the answer in the work for the second problem. Again, I found the common denominator to be 18. I could carry out the list again if you did the 9, 18, 27, and then 6. 6 times 1, 6 times 2, 6 times 3, 6 times 4, and so forth. 18 again is that common denominator. Multiplying both by 2, that's how we get from 9 to 18. Multiplying both by 3, that's how we get from 6 to 18. And then we add the tops again. It's 2 plus 15 is 17 over 18. So the same idea, whether we add or subtract, is being applied. The common denominator between 3 and 5, if I were to carry my list out, is going to be 15. So we have both of these are going to become 15. So 3 times 5 will give me 15. So I've got to multiply the top by 5. 5 times 3 will give me 15. So I've got to multiply the top by 15. And then again we subtract. 5 minus 3 is 2 over the same denominator always. Go ahead and try to do that subtraction. What's the common denominator? What's the new fractions? Alright, for this last one again, the common denominator was 40. And then I changed each of these, multiplying these both by 2, multiplying these both by 5. So we have 22 minus 15 is 7, and then keeping it over the same 40. It kind of went off the screen a little bit, but that is a 40. Now we're moving on to decimals. What we're going to do here is we're going to round to the nearest hundredth. Now the thing is we did with the whole numbers is we know that we start at the decimal and we go ones, tens, hundreds, and so on and so forth. When I'm looking at this number, there is no oneths place. We simply start here at the decimal and go tenths, hundreds, thousands, 10,000s, and so forth. So when I'm going to the nearest hundredth, I'm looking at this number right here. And as always, I'm going to look behind it. So it's telling me, because again this is between 5 and 9, that my number in the hundredth spot is going to go up by 1. And as always, the numbers in front of it don't change. The numbers behind it become 0. So again, this is 2.36. You can drop the zeros. Go ahead and round 45,000 to 45, and then 0.2561 to the nearest thousandth. Hopefully you knew that the one behind it tells it that tells that our thousandth place can stay exactly where it is. And again, everything behind it is 0 or gets dropped off in the decimal, and everything above it stays the same. When I'm looking to compare, the easiest thing for me to do is have equal number of decimal places represented. So I've got tenths, hundredths, thousandths. So I need to have tenths, hundredths, and then thousandths. So now they're in the same place. So I'm comparing 12 and then 190,000th. I see that that is definitely greater than 12 and only 89,000th. So 190 behind the decimal is much bigger than 89. So do the same over here. I have tenths, hundredths, thousandths, 10,000s, tenths, hundreds, thousandths, 10,000ths as well. And hopefully when you see that 130 10,000ths is more than just 14 of them. Now when adding and subtracting decimals, you need to make sure that the place values are lined up, or in other words, that the decimals are lined up. So they've already placed them in with the addition. We've placed them with all the decimal lined up. What I like to do also is put in zeros, just to kind of remind me that there's zeros in these places here. Now it doesn't make so much of a difference when it comes to addition, but it definitely makes a difference when it comes to subtraction. We'll see that in a minute. So then you're simply going to add as you did before. 8 and 0 is 8. 3 and 8 is 11, carry the 1. 2 and 6 is 8 plus 1 more is 9. 2 and 6 is 8. The decimal point stays in the same place. And then 4 plus 2 is 6. So go ahead and add the next one. and you should have gotten 10.2418 for the second problem. Now when it comes to decimals, I wrote them horizontally on purpose because I wanted to get practice in lining up the decimals. So there's 7.2 and then the 3.15. Now in addition, it doesn't make as much of a difference, but here, if I tried to subtract 5 from nothing, there's a temptation just to do 5 and go on with it. But if I put a 0 here, then all of a sudden I see this needs to be a borrowing situation, where I put the 1 here and reduce that down to 1. So 10 minus 5 is 5, 1 minus 1 is 0, and then 7 minus 3 is 4. That's very different if I wouldn't have done any borrowing. So as you set this one up over here, the 9.9 and then the 1.58, make sure you put the zeros in as you work through. Again, once you put the zeros in, you'll notice that I need to borrow here, knock this down to 8. I don't need to do any more borrowing because I can do 8 minus 5 and get 3 just fine. And that should be the end of that problem. Multiplying decimals isn't that much different from multiplying whole numbers. The one thing I'm going to do right now is forget that the decimals are even there. First of all, if you'll notice, I don't have to line them up. That's not necessary. So I'm just going to multiply again the 6 times everything and then the 1 times everything, similar to what we did with whole numbers. So 6 times 1 is 6. 6 times 9 is 54, and then carry the 5. 6 times 9, again, is 54, plus 5 more is 59. So just like before, when I worked one space in, I'm going to put a 0 to start one space in. So 1 times 1 is 1, 1 times 9 is 9, and again 1 times 9 is 9. And I'm not adding the 5, that's from when I worked with my blue numbers, or just multiplying the ones place. And then as always we add down. So if you look so far, the procedure hasn't been any different. The difference is now when I look at my place values, I look at the decimal. I have one decimal place here. In the second number I have 2 decimal places, so I have a total of 3 decimal places. So what we do is we put the decimal from here and we move it 1, 2, 3. So my full answer is 15.856. Not the 15,000, but I have to put the decimal point 3 spaces in because I had a total of 3 spaces in here. So again, do the same thing here, multiplying the 5 by everything, the 1 by everything, and worry about the decimal point at the end. So in this problem, I've multiplied everything through, just using the digits the same way I would with whole numbers, but then at the very end, I have to count the decimal spaces. So 1, 2, 3, 4. That means I have 4 total. So I have to start back here and go 1, 2, 3, 4. So my final answer is 1.2255. Now we're going to do decimal long division. This is very similar to long division with whole numbers, except we have to take care of the decimal at the very beginning. So what we're going to do here is I have to be dividing by a whole number divisor. So I'm going to move this to the back. If it was 2 spaces, I would move it 2 spaces to the back, whatever it takes to get that decimal point behind the numbers. So if I've moved this 1 space to get it to the back, I'm going to move this space 1 space to move it to the back. And what I'm going to do now is I'm going to rewrite what I've got. Sometimes we try to keep track of where the decimal is here. If I rewrite it, so I moved it to the back, so I now have 13, then now here I have 536.9. That decimal is now there. So now it's a lot more clear of where the decimal point lies. And I'm not going to move the decimal point anymore. I know with multiplication we move it at the end. In this case we move it at the beginning. So then we're going to carry decimal division the same way we carry regular long division. 13 can't go into 5, so I'm going to put a 0 there just to kind of hold that spot. Where we put these numbers is very, very important. So 13 can go into 53 4 times. If I make a list, for example, 13 times 1, 13 times 2, 13 times 3, 13 times 4, and so on and so forth, 13 times 5, then I notice I can go 1, 2, 3, 4, but going to 65 is larger than that. So 13 times 4 will be the one that we want. So it's 52. I wrote that wrong. 52. We subtract, and then we bring the next number down. Then we repeat it again. 13 goes into 16 one time. 1 times 13 is 13. We subtract, and then we bring the next number down. 13 goes into 39 three times. We multiply, we subtract, and if I wanted to, I don't need to, but if I wanted to, I could put zeros here on the end to carry out a longer decimal answer, but I don't have to do that. The last step that we're going to do is we're going to take the decimal point straight up from where it was, which is right here. So my final answer is 41.3. When I'm going to allow you to do this in a second, but when I'm looking at this, there is no decimal that needs to move at all. 7 is already a whole number, so I'm simply going to do the long division with my decimals. So finishing this division, I get 992, but again, the decimal goes straight up from where it was before. So it's behind the 9 and in front of the 2. So my answer is 99.2. 36. Now that you've completed the worksheet, what do you do now? Well, you might want to go back on some of the topics and practice using the worksheet links that were provided for you. You might feel that you're ready to take the AccuPlacer test or any other placement tests. Keep in mind that this is not a guarantee that you would get into a particular course. This is simply to help remind you of some of the skills you may have forgotten. Good luck on your placement test, and good luck on the rest of your courses.